Welcome back guys. We are going to start our next lecture video of the topic solution colligative properties, in which we are studying colligative properties. We have discussed what is colligative properties, which depends solely on the number of solid particles. Colligative properties are of four types that we have to study. The first one is lowering vapor pressure. Second one is our second colligative property is elevation in boiling point. So this is the only one. Let's begin. So elevation in boiling point. So the boiling point of water is, that is 373.15 Kelvin, 100 degrees Celsius. When we add 1 mole of sucrose, right? When we add one 1 mole of sucrose in 1000 gram of water, then boiling point of water will increase from 373.15 Kelvin to 373.52 Kelvin, right? 373.52 Kelvin, just adding 1 mole of sucrose in 1000 gram of water. It means the boiling point of the water will increase, or in terms of vapor pressure of the solution is decrease, because no solute will occupy the surface of the solvent, and number of molecule existing or entering the vapor phase from the solvent is decreases, right? The solution and the solution boiling point is increases. So there is a graph which we have to study it. This one, before talking about anything about the graph, first there is a equation, that is TB, delta TB is equal to TB minus TB naught. So delta TB is the change in temperature which is being brought when 1 mole of sucrose is added in 1000 gram of water. So delta TB naught is the boiling point of pure water, right? And delta TB, your TB is boiling point of the solution, and TB naught is the boiling point of pure water. TB is solution. So this one is your for solution, and this one is pure water. तो जो जहाँ पर भी नॉट दिख रहा है ना, वी हैव टू स्टडी दैट्स पी नॉट. तो नॉट इज फॉर प्योर, राइट? प्योर सॉल्वेंट, प्योर सॉलिड. So delta TB naught is for pure water, that is 373.15, or TB is for solution when you add 1 mole of sucrose in 1000 gram of water. And TB is the change in temperature. So if we see what is the change in temperature when we add 1 mole of sucrose in 1000 gram of water, then we simply says delta TB is equal to, that is 373.5, that is boiling point of solution, minus 373.15, that is boiling point of pure water. So what we get, the value of TB will be, what is the value of TB? That is 3.73 Kelvin is the value of TB, that is change in temperature. Now we are going to discuss about this graph. The graph is very simple, there is not much complicated, you can get it very easily. So here there are two temperatures we have noticed, that is first is TB naught, that is the boiling point of pure water, and TB, that is boiling point of solution. The TB is greater somehow and TB naught is lower. So if you just take x-axis temperature and y-axis vapor pressure, so what you will find, TB is less, so TB will appear first in the graph on the temperature scale, and TB naught, and TB is more, so TB will appear after TB naught because it is higher in temperature. Here simply 1 atm we have taken 1 atm, because why we taken 1 atm, so we have to why pressure is 1 atm we have taken, because uh, we are present the room, the present atmospheric pressure is 1 atm we have taken, or 1.013 bar. And the what is the definition of boiling point? सो किसी भी लिक्विड का बॉइलिंग पॉइंट कब आता है? जब एटमॉस्फेरिक प्रेशर इक्वल हो जाता है वेपर प्रेशर के। जब एटमॉस्फेरिक प्रेशर इक्वल हो जाएगा वेपर प्रेशर के, तब हमारा बॉइलिंग पॉइंट अचीव होगा, राइट। तभी हमारा बॉइलिंग पॉइंट अचीव होगा किसी भी सोल्यूशन का। एटमॉस्फेरिक प्रेशर और वेपर प्रेशर जब इक्वल हो जाएगा तो आपको बॉइलिंग पॉइंट अचीव हो जाएगा, राइट। ये सिंपल सी डेफिनेशन है बॉइलिंग पॉइंट की। नो वन इज गोइंग टू आस्क फ्रॉम यू व्हाट इज बॉइलिंग पॉइंट। सो इफ यू डोंट नो यू कैन राइट डेफिनेशन, इट इज गिवन इन एनसीईआरटी। सो 1 atm is the current atmospheric pressure that we are living in। जो भी आसपास जिस टेम्परेचर जिस एटमॉस्फेरिक प्रेशर आपके रूम में है वो क्या है? 1 atm है। और 1 atm ही एटमॉस्फेरिक प्रेशर है, और इसी एटमॉस्फेरिक प्रेशर के जब वेपर प्रेशर इक्वल हो जाएगा उस वाटर का जो उसको बॉइल कर रहा हूँ, तब आपको क्या अचीव हो जाएगा? बॉइलिंग पॉइंट, राइट। सो वी हैव टेकन एटीएम हेयर, तो एक एटीएम पे ही हमारा बॉइलिंग पॉइंट आएगा, राइट। एक एटीएम पे हमारा बॉइलिंग पॉइंट आएगा। तो ये सॉल्वेंट का है, ठीक है, सॉल्वेंट का प्योर है, ये पहले आएगा और सॉल्यूशन का बाद में आएगा। तो एक सिंपल सा ग्राफ है सॉल्वेंट और सॉल्यूशन का, और इन दोनों का ही जो चेंज होगा, जो डिफरेंस होगा, वही हमारा क्या देगा? डेल्टा टीवी देगा, राइट। अब जो डेल्टा टीवी है, जो आपका डेल्टा टीवी है, जो डेल्टा टीवी है इसको हम बोलते हैं एलिवेशन ऑफ बॉइलिंग पॉइंट। इन नोट्स इट इज रिटन क्लियरली, सो डोंट वरी अबाउट दैट, एवरीथिंग विल बी फाइंड इन नोट्स, जस्ट लिसन इट केयरफुली। सो डेल्टा टीवी इज योर व्हाट? इट इज एलिवेशन ऑफ बॉइलिंग पॉइंट, यानी कि बॉइलिंग पॉइंट में कितना एलिवेशन हो रहा है। सो there are a number of experiments have been done on the basis of experimental data. It is found that delta TB is directly proportional to molality, right? Delta TV is directly proportional to molality. So if we remove the symbol of proportionality constant, proportionality we are going to put a constant, and here it's your kV is your constant and m is your molality, right? तो एक्सपेरिमेंटल बेसिस पे हमने देखा है कि जो डेल्टा टी भी होगा, जो एलिवेशन बॉइलिंग पॉइंट होगा, वो किसके प्रोपोर्शनल होगा? मोलैलिटी का प्रोपोर्शनल होगा। अब प्रोपोर्शनलिटी का साइन हटाएंगे तो हम एक कांस्टेंट पुट करते हैं, यहाँ पर हमने जो कांस्टेंट पुट किया वो है हमारा के बी, और एम हमारा क्या है? मोलैलिटी। एम इज योर मोलैलिटी, ऑलवेज रिमेंबर दिस थिंग। So things are very much clear here. So delta TB is proportional to molality, delta TB is equal to KBM. KB is your what? Proportionality constant. Now this constant has three names. Always this thing has asked in exam many times, so you must remember all these three names. In exam, examiner can ask KB by via any number. Okay, so it's your responsibility to learn all three names. So first name is boiling point elevation constant, second is molar elevation constant, and third one is ebullioscopic constant. So KB has three names, right? So you must remember three names. First, boiling point elevation constant. First one is your boiling point elevation constant, second one is molar elevation constant, and third one is ebullioscopic constant, right? So now if I simply ask you what is morality, we have discussed earlier what is morality. Let me change the color. Okay, what is morality? So number of moles of solute dissolved in 1000 gram or 1 kg of solvent. Yeah, this is the definition of morality. So okay, let's start. So molality is number of moles of solute. So in NCERT, it is W2 by M2, that is number of moles of solute dissolved in W1 by 1000. So W1 by 1000. In NCERT, weight of solvent is taken W1, and weight of solute is taken is W2, and mass of molar mass of solute is M2. So W1 by 1000 is what? W1 by 1000 is what? W1 is a weight which we have to take in. Suppose if the question asks that you are going to make a molar solution in 500 gram of solution, then you have to convert it into 1000 grams. That's why I have taken W1 by 1000. And W2 is what? It is the weight in gram of solute. M2 is what? Molar mass of solute. So I'm going to rearrange this. That's molality will become W2 by M2 into W1 into 1000. So this is the formula of molality that will appear, right? So the same thing you will find here, 1000 into W2 by M2 into W1. So delta TB is equal to KB into M. So we are going to put the value of M here, right? So the value of we have calculated here, try from the formula. So we are going to put the final equation look like this: the delta TB into KB, and this part is your molality, right? So this part is your molality. And now we are going to arrange whole this formula in terms of molar mass of solute. Suppose you have dissolved any solute weight in gram, and you have question is going to ask what is the molar mass of that solute. So you have to calculate for M2. So this is the rearrangement of the formula only, right? Now we are going to do one question. 18 gram of glucose C6H12O6 is dissolved in 1 kg of water, right? So 1 kg of water is your, this is your solvent, this is your solute. So molar mass of glucose is 180 gram. Number of moles of glucose, so weight in gram of solute by glucose by molar mass of glucose, that is 18 by 180, it will become 0.1 mole. And already it is given there's 1 kg of water, so we have to dissolve number of in molality we have to dissolve our solute in 1 kg of water. So already it is 1 kg of water, then simply 0.1 mole per kg, that is 1. So our molality will become 0.1 mole per kg. The question is very much easy. Now what is the next part of the question? In a saucepan, at what temperature will water boil? Will water boil at 101, that is 1 atm. It is given in bar. 1 atm is equal to 1.013 bar, right? One by ball at 1.013 bar. KB of water, right? So KB constant, ebullioscopic constant value is given. Elevation boiling point water constant value is given, that is 0.52. So simply we have calculated the molality. Now we are going to calculate delta TB. So delta TB is equal to KB into M. KB is about what? It is given in the question 0.1. That is the molality we have calculated. So overall it will become 0.05 Kelvin. So we have taken water. So we have taken water, and we know the boiling point of water, that is 373.15 Kelvin, right? So now we have to what they asked us. Let me check. At what temperature will water boil, right? So they are asking about the solution temperature. So they are asking the solution temperature. Simply you just need to add and you will get the answer, right? So second question you perform by yourself, and now we are going to start our next topic in our next lecture video.